All right, so now we're going to talk about site planning. So first, you want to go ahead and gather information. So maybe doing some soil maps. So in your assignments, I want you guys to, if you do have soil maps, I want you to show them. And the other thing is boundary mapping as well. So actually map out where your vineyard's going to go. And also in your assignments, we really want to see that you've chosen a specific spot for your vineyard. So I want to see some kind of map of your site, so we know exactly where it is. And then what we're going to do is we're going to start blueprinting out where the blocks are going to go, and then what varieties and rootstocks we're going to put out. And we'll talk about varieties and rootstocks in the last lecture, last class that I do. Then we want to start considering row orientation, plant spacing, design of in all of our infrastructure like irrigation, trellising. If we're going to need to put out any windbreaks, and then if so, how are we going to do that? Are we going to do windbreaks with like poplars, which is a pretty popular windbreak in New Zealand, or are we going to use like something synthetic like nets to break wind? And then also just like figuring out where we're going to put the other parts of the farm, like the tractor shed, where we're going to keep all of our equipment, or also the chemical shed, where we keep all of our sprays and herbicides, all that stuff. So there's a lot to actually plan out here. So with soil mapping, we can do traditional soil maps where we could go out and actually get someone to come out and map our soils for us. So these would be like professional soil folks in our areas that can come out and do kind of much finer, detailed soil mapping, or we could just use something like the soil surveys in our countries. Like in our case, we have the USDA NRCS soil survey, and use just that as a give us a rough idea of what we have. There are things that we can use, like the Trimble soil information systems, which give us kind of more functional data about our soils across the area, which is something that I've been using for a while. It seems to work pretty well. It's of course not perfect, but it gives you an idea of things like textural changes and chemical changes across your farm. So then what we might do is go through and actually map out the boundary of our soil, of our vineyard. And this is something I would like y'all to do in your assignments and actually come back with. I would use just Google Earth Pro and make polygons around your vineyard area. If you don't know how to do that, if you just Google or like you YouTube a video on just like creating polygons in Google Earth Pro, you'll see how to do it. It's quite easy. You have to download Google Earth Pro to do it, but it's very simple. And then it can also, once you create a polygon in Google Earth Pro, it'll give you area information, so you can see like how big is your vineyard, that sort of thing. You can also find elevation and stuff when you do that in Google Earth. And I want to know elevation of the vineyard. Yeah, and then so you'll start mapping out the plantable area, remembering to leave headlands. So remember, we have to turn at the end of rows with tractors. So generally we say we leave about 30 to 50 feet of headlands. 50 feet's a much easier headland to manage, but if we really need to use the space, we can go down to 30 feet and do okay. But yeah, so you can see here there's actually quite a big reduction in plantable acreage if we move from 50 feet to 30 feet. There's a 50% reduction when we go into the 50% or the 50-foot headland. So then we'll go ahead and mark blocks out. This you don't have to do for your assignment, but I want to discuss the practicality of blocking. And the reason generally what we're trying to do with blocks is create areas of uniformity. We don't want to have extreme variability in a block. Of course, there's really no way for us to make a totally uniform block, but that's kind of the goal. But we have to consider things like, are we going to have big, easily managed blocks, where we're probably going to have maybe more variability if we do that, or are we going to have a bunch of small blocks, but that's going to increase like managerial complexity on the farm. So like one thing that's really nice in the Central Valley is that on a lot of those farms, they have relatively homogeneous soils, so they can have 100-acre blocks and have pretty homogeneous growth in there. But then say if you're in New Zealand, so New Zealand has a lot of really young soils, and there's just a ton of like geological activity in New Zealand, and tons of different ways of soils being formed. And so there's like, you'll be on a farm and there'll just be like an incredible variation in soil types all around that farm. And yeah, so if you had these large blocks, you're going to have just remarkable variability using large blocks in New Zealand. So you might consider going to a smaller block sizes in order to make more uniform growth within those blocks, right? Because if the growth is not uniform, then you're going to have issues where, like, for instance, you want to go pick one whole block at once, but you might have like 20% of the block which is quite stunted in growth and not ripe, and then the other stuff is ripe. So you go in and you're picking 20%, which actually is not optimal. So ideally, we want all of our fruit to be picked at an optimal ripeness. So that's just something you need to consider. Then we'll choose our varieties. We're going to go over varieties and rootstocks again at the last lecture that I give you all. But this is going to be, of course, dependent on the growing region. What is the brand of the growing region? So brand Oregon is Pinot Noir. We're trying to push Chardonnay as well on the market and sparkling wine. But brand Oregon really is Pinot, so maybe we're going to go with Pinot. But, maybe with market trends, we're not going to choose Pinot Noir for Oregon, potentially, right? Because Oregon Pinot sales maybe are kind of flattening out a little bit. But we are seeing growth, though, in the Oregon market, by the way, currently, which is nice. We can't really say the same for California. They're in a bit of a wine glut at the moment. But Oregon, interestingly, is increasing in sales. But that's something we need to consider is our fruit actually going to sell, and is our wine going to sell? So maybe we want to do some Pinot in Oregon. Maybe we want to do some Gamay, because Gamay seems to be increasing in popularity. Maybe we want to do a little bit of Chardonnay, because we can't get enough Chardonnay right now in Oregon. So maybe we kind of want to diversify what we're planting out. Of course, if we're in Burgundy and we're in the Côte d'Or, like say we're up in the Côte de Nuit, we're going to want to plant Pinot, right? We don't really have much of a choice. That's what we need to plant, because that's what's going to sell. Also like what your winery needs, of course, and the value of that crop. Do we want to plant, Muscat in Sonoma? Probably not. There really isn't, Muscat, of course, is very popular, but there isn't really much Muscat in Sonoma, because Sonoma is high-value land. So you really need to have a high-value crop, and the Muscat is not really a high-value crop. So you see a lot of Muscat of Alexandria in the Central Valley. There is a little bit of Muscat Blanc in Sonoma, but I think it's only about 70 acres or something. Maybe even it's less than that. I think it's 70 tons is what was crushed. Then we got to consider, of course, climatic things, GDDs, frost-free days, to make sure we can get stuff ripe. And then, of course, soil characteristics. So one thing we might do is if we have a really vigorous area, like on the lower part of a vineyard, we might plant that in whites. And then the lower vigorous stuff, we might plant in reds. And that's because with whites, we're not necessarily trying to build up like phenolics, and we really don't. We're really trying to minimize phenolic accumulation in white varieties. So putting them on more vigorous areas is maybe better just because we're gonna get less light into that canopy and build up less phenolics. We're of course gonna build up less flavor as well, but also reds are a higher value crop always. So we're generally going to want to use the land that is going to create kind of lower vigor red vines, because we want to get more sunlight and heat onto that fruit to increase the flavors and increase the phenolics, make them, make it a higher quality, because those are our higher value. Those are generally going to be our higher value products. And then we're going to need to choose rootstocks. Again, we're going to go over this in the last lecture, but all of our rootstocks are phylloxera tolerant. So remember, they're phylloxera tolerant, not phylloxera resistant. There is still going to be a high population of phylloxera if there is phylloxera in that soil. Like, there's still going to be a high population of phylloxera on rootstock. So these rootstocks can support the same population numbers of phylloxera that an own-rooted vineyard would have. It's just that the rootstocks, the North American rootstocks, are tolerant of the phylloxera. And remember, phylloxera are just root louses that chew on the roots, and then they open up the vascular tissue to the soil, and then fungal pathogens from the soil can get into the vascular tissue, occlude it, and then the vine goes through water stress, which can't be ameliorated through irrigation because the vascular tissue is being occluded, and then the vine just dies. In some areas with sandier soils, phylloxera may not be an issue. Like I saw this in Central Otago when I was doing due diligence on a farm, and it was it wasn't that far from the farm where phylloxera was first found in Central Otago, like in 1991 or 92, and there was a bunch of unrooted vines on this farm, and so we were concerned that phylloxera might be there. So I went around for half of a day and dug around the roots and looked at roots for evidence of phylloxera using a hand lens. Could never find it, and then eventually I was just like feeling the soil in my hand, and there was a bit of a grit to it, and I realized I'm dealing with a sandy soil. So they tend to not live in sandy soils, and also areas with really cold winters seem to keep them away potentially. So Walla Walla, Washington, really doesn't have much phylloxera. There have been some reports of further failures to phylloxera in Walla Walla recently, and they're attributing that maybe to some warmer winters they've had. So we may see Walla Walla fail at some point. But right now, most of Eastern Washington is own-rooted because they really haven't had this issue. Chile as well is mostly own-rooted. And in Chile, it's not because of cold winters or sandy soils. They have moderate winters, and they have soil textures of all different textures. Chile is probably really just a matter of time. It's kind of amazing it hasn't collapsed yet to phylloxera, but once phylloxera moves to Chile, it probably will move through Chile quite rapidly. So yeah, one thing just to remember is we've had phylloxera failures even on rootstocks in the United States. We had a rootstock that was really popular called AXR1, which was Vitis vinifera by rupestris. And it was really popular because only because it was being pushed by nurseries, because it was simply easy for them to graft it because it had vinifera in its parentage. So you had really high take rates. So for a nursery, this is a heck of a rootstock because they're not wasting their time. So we had a lot of this planted out, and in the 80s and early 90s, we had a massive failure of this rootstock, especially in Napa, which caused over 60% of the acreage in Napa to be replanted. Right, so now there's actually not that many vineyards older than the early 90s in Napa. So here's just like a chart we use, and I'm going to go over these in greater detail in a later lecture, but this is a chart that many of us will use, or various charts like these to decide what rootstocks we're going to use. The most common ones that we're using are Riparius birupestris rootstocks. So Riparia Lyre, which is a straight up Vitis riparia. 10114, which is Riparia birupestris. 3309, which is Riparia rupestris. And some of these are also have Berlandieri in their parentage. I think 5C might be. I can't actually recall off the top of my head. I think 110R might have Berlandieri. But we'll go over this in a later lecture. But what you can see is like, so everything is kind of high phylloxera resistance. I don't know why freedom isn't. We can dive into that later. These are interesting, like these ones like freedom. I think this is one, and Dog Ridge, which is like medium. These I think are used in the Central Valley, like possibly on salty soils. I'm pretty sure Dog Ridge. I know Dog Ridge is used for salty soil. Yeah, there you can see medium to high salt tolerance. Freedom, no, I don't. I guess freedom is nematode resistant. We don't really see this too often. Grovstock's an interesting one. That's one that's used in soils with really high lime concentration, because you deal with what we call lime-induced chlorosis in high lime soils, which is really just an iron deficiency. These GRN rootstocks are new rootstocks that are that have high nematode resistance and even can be resistant to fan leaf virus. But yeah, so this is kind of this is one of the things we'll look at to plan out what rootstocks we're going to use. And then trellising is dependent upon a lot of different factors, right? So production goals like yield and quality, trellising is going to have a big impact on that. The more buds we leave, right, the higher our yields are going to be. But potentially we can get to such high yields that we can't even get it ripe commercially, right? So that's going to degrade quality. We also need to consider things like budgets. Some trellising is going to be more labor intensive in season than other trellising. So that's going to increase our operational spend. Of course, some trellis is going to just require more stuff. So the initial capital required to put that trellis in is going to be higher. We'll need to consider things like even like aesthetics, which of course is not scientific, but you know, this industry, you know, a lot of people get into this industry for romantic reasons. So they have houses on vineyards, and they may not want to see oil posts used for end posts because they don't like the look of metal posts for some reason. So you may go with wooden posts for that. Also things like variety, right? So some varieties are going to be better trellised on, you know, different systems. A lot of people believe that Zinfandel, like in California, should all be head trained. And I think that's largely because when you head train a vine and when the shoots drape out, they cover the fruit a bit. And in California, it's quite hot, and the Zinfandel, if it's fully exposed, can sunburn. So the head training helps prevent the sunburn. And then say in New Zealand with Sauvignon Blanc, you might want to do VSP because it's quite cool, and VSP in moderate to low vigor situations can provide a nice open fruit zone. We can get a lot of light and infrared radiation, warm up that fruit, and get that fruit ripe. We don't really want to occlude the fruit in New Zealand with leaves because then we'll get like green aromas and then we won't get ripe, right? And so yeah, growing environment kind of plays into that as well. So those cooler climates, we're going to want to have more open fruit zones than in those warm climates. And really hot climates, we may actually want to put some leaves in front of the fruit to keep the heat load down so that it doesn't sunburn. So we break training systems up into like 3 big categories, right? And this is of course not including head trained. Head trained would not have a trellis. It's just like a freestanding grapevine. So this is just for trellises. So we can break it into single curtain systems, which are like VSP, or high wire, what we call Sprawl, California Sprawl, or smart Dyson, which we generally don't see anymore. I'm not even going to discuss it any further, but if you want to look it up, you can. And then we can do vertical divisions in canopies. These vertically divided canopies are usually retrofits. We usually don't start a vineyard with this in mind. It's usually what happens. Usually what happens here is they start with vertical shoot positioning. Then they see, oh man, I got a lot of vigor. I need to leave more shoots per linear foot. Then they might go from cane pruned VSP to spur pruned VSP to leave more shoots per linear foot. And then they're like, oh, I still have high vigor. Now what do I do? Then you might convert to one of these vertical divisions. So yeah, there's Scott Henry and Smart Henry, which are very close. We'll just look at Scott Henry because that's mostly what we see. And then you can also do things like horizontal divisions as well. And the most common one we'll see is Lyre. Geneva double curtain is what's used. This was developed by Cornell, and that's what's used for a lot of Concord in New York. And it's just basically high wire, but with like horizontally divided high wire, right? So you have like 4 canes or 4 cordons, and then the shoots drape down. All right, so this is VSP. It's the most common system that we see, not only in my home state of Oregon, it's the most common system that we see really all over the United States, rightly or wrongly, probably wrongly, to be honest. I think the reason we see VSP so commonly is simply because it's the devil we know. It's not necessarily the best system for some areas, especially like the Finger Lakes where it's extremely vigorous here. This system is not the best for really vigorous vineyards. But for really vigorous vineyards, we need to leave more buds than this allows. So we need to do some sort of division on high vigor vineyards. Generally, we see either bilateral cane or cordon, or if it's closely spaced, like a meter apart from vine to vine, then we'll see unilateral. This is how it looks. This would be a 3-wire system. Sometimes you can see people will do 2 wires, but you have to take the shoots and position them so they're growing vertically between these wires. So there's a lot of in-season work that has to be done with VSP. A lot of expense to make this thing work. You got to position the shoots, clip the wires together. Yeah, it's a lot of work. And then the expense of the trellis itself is quite high, right? This is unilateral cane. This is what you see in Burgundy. This is when you are meter by meter. This would be double guyot. Guyot is cane prune, but for French. So this would be what we also call bilateral cane. Right. So Marlborough is basically all bilateral cane VSP. So you can see it as far as the eye can see through the valley. You can see some people doing these like Tri-lateral where they do like 2 fruiting wires, and they do like this is what you'll see oftentimes here in the Finger Lakes because they have so much vigor here. It causes a lot of canopy congestion, which is why I don't think this is necessarily the best system in high vigor areas. Like this is what they're doing to attenuate vigor, but there's better ways to attenuate vigor where you don't get as much canopy congestion. And then of course you can do quad where you have 2 fruiting wires and everything growing up. But again, this fruiting zone here, this upper fruiting zone, is going to have a lot of canopy congestion because you not only have the leaves from the shoots arising from this cane or cordon, but you're also going to have all the shoots that are coming up into it from the bottom one. So again, this is probably not the best way to set up a trellis in a high vigor situation. And the only reason you would do quadrilateral would be because you want to leave more buds. And so there's better ways to do that. So yeah, VSP is typically used for kind of cool climate, high quality growing regions, and it's best for kind of moderate to low vigor sites. If you're on high vigor sites, then there are better ways to leave more buds, and that might be either through just spur pruning or going to a divided canopy of some sort. It does allow for narrow spacing between rows. Remember, with trellising, we always try to do, we call it it's a 1-to-1 ratio. So it's the canopy height to row width. So if the canopy is 7 feet high, then the row width should be no shorter than 7 feet. And that's so that we don't get a bunch of shading from fruit zone or from one canopy into the fruit zone of the other. Yeah, this VSP requires a lot of in-season costs because you have to do all that shoot positioning and wire lifting. So for sprawling systems, we don't have to do all that canopy management, which is quite nice. But we really don't want to do sprawling systems probably in cool climates because we want to open up that fruit zone and get as much light into the fruit as possible to get it ripe. So yeah, the cost for materials for a VSP trellis can be somewhere around $4,500 per acre. So it's quite expensive. So yeah, its advantages are for cool climates and low to moderate vigor sites. Then we can end up with quite high quality fruit because we have a nice open fruit zone, especially when we remove leaves on those canopies. The disadvantages, of course, is that it's quite expensive. It's one of our more expensive trellis options, and it's labor intensive. So not only your initial capital outlay, but then your ongoing management costs are going to be high with this system. And it's also kind of hard to mechanize. High wire which is a sprawling system used in California and also used on a lot of hybrids in Concord. That system is very easy to mechanize a lot of the operations. And in fact, high wire, we can do what we call kind of no-touch vineyards where we don't even use hand labor. Yeah, so, we can also we don't have to do it with canes, VSP with canes. We can also do it with cordon and spurs. This is a diagram of that, showing the fruiting wire. We're about 32 inches off the ground, which is about waist height. And the only reason we are trellising is that high, by the way, is because it makes it easier operationally for people to pick it. And then you can see from the fruiting wire to the catch wire, the first catch wire, we're about 10 inches. And then there's another catch wire here, and one there. In this instance, I don't know why they have 4 catch wires. That's a little excessive. We generally only do 3 pairs. This is a system. This is a sprawling system. What we call California Sprawl or high wire. It's the same thing. And what we do here is this is almost always cordon spur pruned, unless it's Thompson seedless. And Thompson seedless is cane pruned because Thompson seedless has very low fertility buds in nodal positions 1 and 2. But what you'll have is, you'll have the fruiting wire here. You put your cordons up there. You can see it's 54 inches off the ground, so it's up high. And then you'll have another permanent wire about 1 foot off. And what happens is the shoots grow up, and then they start to drape over that permanent wire. And then that allows, the reason you have that permanent wire is to allow it to kind of drape over the fruit, and then you can kind of occlude the fruit from the hot sun. So this is especially useful in the Central Valley of California, where they, regularly will get days above 100 degrees Fahrenheit for a month or two, which would cause significant sunburn if they didn't put leaves in front of the fruit. So sometimes you'll see systems where they don't even have that wire, that top wire. It's just draping out, which is fine as well. It's very easy to mechanize this. You can do what's called box pruning in here, which you just mechanize the pruning, where you don't really care to be exact about how many buds you're leaving. You're just getting it roughly right, where you just go through and you just cut it with it. Essentially, it looks kind of like table saws in a box shape, and the spurs are going every which way, and it looks like a bit of a mess, but it works. And we're not trying to, in that situation, we're not trying to farm, ultra premium luxury wines. We're farming for more mass production. Yeah, the cost of this kind of trellis system is very low because you only need to have the 2 wires. You have really very minimal in-season management costs because you're not doing all the positioning that you would with VSP. So yeah, it's generally something we use for kind of lower value, high volume crops in typically in the warmer hot climates, because we don't really necessarily need an open fruit zone. So that's what it looks like in the Central Valley, where it's just sprawling out and you can't see the fruit at all. And then this will be machine harvested at some point. Yeah. we did see it in Oregon as well. In the older vineyards, people were doing this, and that's because simply just because it was cheap for them to do it. In Oregon, a lot of folks in these vineyards didn't put wires up above, like 12 inches above the fruiting wire. So, like, if we go back here, you can see that foliage support wire. They didn't put that there, so it was just draping out. And that when you do that, if it just drapes without going over the wire, then that fruit's more exposed. And it's very well exposed. And in some years, if on vineyards like that, we can have quite a bit of sunburn. So what I've seen a lot of folks doing is actually retrofitting those sprawling trellises. They still like the sprawling trellises because they're cheap to manage. But what they're doing now is just adding that foliage wire up top in order to avoid that sunburn. Because we've had hotter years the last kind of like 3 years in Oregon, 4 years. Yeah. So some other systems, this is a vertical division. This is Scott Henry. So again, this would be generally done when you kind of made a mistake and you put in VSP and you can't attenuate the vigor using spur pruning. So now you need to divide the canopy, and you probably can't. So say if you did 7-foot rows, you couldn't do a horizontal division because like you couldn't do a Lyre system because your rows are too close together. And then if you do a horizontal division, you won't be able to get your tractor down the row. So you're going to do a vertical division. So what happens here, this is always a cane prune system. So you've got bilateral cane there, bilateral cane there. These are growing up, these are growing down. What ends up, how you do this is these shoots grow up in the beginning of the season, and then when they're about 2 to 3 feet, you're going to flip them out, and then you're going to capture them with a wire. I like to use a wire down here to capture the shoots and hold them down. If you don't use a wire, the shoots just kind of go out into the row, and then you'll run over them with the tractor and rip them off. But yeah, these are good on high vigor sites, this system. It does require more management than a VSP system because you do have to do that roll. And then also, so that there's that roll, then you still have to do all the shoot positioning and wire lifting that you would with VSP. So you have high management costs with this. And of course, the cost of materials is slightly higher than VSP because you need to add another fruiting wire and then the wire down below, another catch wire. So it's slightly higher. But it can produce high quality wines. This is John Dyson's brand. So John Dyson is the fella who's responsible for the Dyson School here at Cornell. And this wine here was, I think it's about 55, $60 bottle of Chardonnay and a consistent high score in the major publications. And this was grown on Scott Henry. So there it is in practice. Actually, I think this is not necessarily Scott Henry. This is whatever Smart Henry, which is the cordon spur prune version. But still, it's very similar, where you have downward shoots and then upward shoots and 2 distinct fruit zones. Yeah, this just kind of goes over what I said. This is just, I'm going to go ahead and skip through this slide if you want to pause and look at it. This is more just practically how to do Scott Henry. Again, this is a diagram showing how it looks, especially, and then what it's showing, these shoots here, these are coming from renewal positions, renewal spurs. So yeah, ideally with Scott Henry, where we have 7 to 8 foot canopy heights and row widths. Again, remember it's 1-to-1 is canopy height to row width, so that we're not shading out the fruit zone in the adjacent row. Like I said, it's a good retrofit. And then if we retrofit, like if we had really high vigor in our, say, cane prune Pinot Noir, and then we retrofit and we start leaving, twice the number of buds in Scott Henry and we attenuate vigor. By doing that, right, we're going to get less lateral growth, less canopy congestion, more sunlight and heat onto that fruit, and then we're going to develop more colors and phenolics and flavors. And so we can actually make fruit better by leaving more buds and actually cropping higher because we're attenuating vigor. We'll get less disease pressure potentially because, again, we're getting less lateral growth, less canopy congestion, and then we might even ripen stuff a little bit earlier because that fruit's getting warmer because it's getting more sunlight. So if you're on high vigor sites, areas where you know you're going to have quite high vigor, you may consider doing wider plant spacing or maybe even spur pruning, or choose another trellis. So maybe you want to do like a horizontal division, which is going to be easier to manage than having to roll Scott Henry down or something, or having downward spurs. So a horizontal division, which is very common, is the Lyre system. Basically, you can think of Lyre just like VSP, but with 4 canes. And then you have like about a foot or 2 from here to here, and then you have these angled out. And the reason you angle the Lyre rather than go vertically is so you can get kind of maximum sunlight inclusion into your fruit zone. Right, so there it is again, sort of that angled system. But basically VSP, but at an angle, and you just, you've divided horizontally. So it's great for high vigor sites. It's obviously very expensive for the material because, you just have a lot of it. You can do cane or cordon. It does require relatively wide row spacing because you want about, this says 3 feet between fruit zones. You can really do 2 feet. I've seen people do 1 foot. I think that's a little bit too narrow. But somewhere between 2 to 3 feet between the fruit zones. And in general, you get pretty good light inclusion with the Lyre. Not necessarily as good as VSP, but you still get quite a lot of light in there if you do this right. One thing you may do, and one thing a lot of high quality producers will do with Lyre, is they'll go through and actually remove inner leaves by hand on the afternoon side. So if you're in north-south rows, they'll remove the inner leaves of this canopy on that west side by hand, because it can get quite congested with leaves in the middle of that Lyre system, which can increase costs a little bit in managing it. So these are the kind of common systems, right? So you've got cordon, so single and double cordon, and then single and double cane, and then these are the various trellising systems that are used, right? So beyond VSP, right? So Geneva double curtain is mostly for it's kind of this sprawling system that's mostly used for concord, juice grapes. Scott Henry here, of course, the retrofit from VSP. The pergola system, which we really don't see used around the world that often. We do see it in like Rias Baixas in northwestern Spain, and this is used in areas where there's a lot of rainfall, and then the leaves are above the fruit so that they kind of act as like an umbrella for the fruit. So you also see a lot of it in the major grape growing regions of Japan. They have monsoon rains. Then of course you have Lyre, and then head trained vines or goblet vines, which are just freestanding vines without trellis, and they're spur pruned, and then they just drape out on the ground and occlude the fruit from sun. You can actually take you can have a stake here and then tie the shoots up to a stake if you want to open up the fruit zone of a goblet trained vine, which people do in some areas simply they use this in cool climate areas simply because the cost of trellis material is so high, so they can just do these freestanding vines. And then these basket vines are very unique. We really don't see them anywhere in the world except for like Greece. There's areas in Greece where they do this. Famously on Santorini, the island of Santorini, they grow grapevines in this fashion. So they're interesting to look at if you're curious about baskets. The reason they do this is, again, it's low cost because they don't need trellis, but also they want them low to the ground because the winds are quite high, and then so you keep it low, and then they're not as impacted by the wind. So another thing we need to consider is row orientation, and perhaps I'll cover row orientation in the next part.